In this video, we will learn that how to solve equations of various degrees and when will be their roots be real numbers and when will be their roots are complex numbers. So let's start with quadratic equation. We know that a quadratic equation is a equation of degree 2 and can be written as follows: ax square plus bx plus c equals to 0. And we can solve our quadratic equation using quadratic formula, which is that x is equals to minus b plus minus b square minus 4ac square root divided by 2a. In this equation, in quadratic equations, the coefficient a cannot be equals to 0. So a cannot be equals to 0, whereas b and c may or may not be 0. They can be 0. In the quadratic equation, this part b square minus 4ac is very important because the value of b square minus 4ac tells us if my solution will be real or it will have complex roots or my solution will be distinct or not. So let's see different cases. Case 1. B square minus 4ac is greater than 0. In this case, I will have real solution and my two roots will be distinct. That means they will not be equal to each other. So in this case, I will have two roots alpha and beta that belongs to a set of real numbers, and alpha will not be equals to beta. Now let's see case number 2. In case number 2, my value of b square minus 4ac is equals to 0. In this case, I will have two real roots, alpha and beta, but they will not be distinct. That means alpha will be equals to beta. They will be same. In my case 3 is that my value of b square minus 4ac is less than 0. In this case, I will have complex roots. So my two roots alpha and beta belongs to a set of complex numbers. Moreover, alpha and beta will be conjugate to each other. That means we can say that beta will be equals to alpha conjugate. That means it will be same as alpha, but the sign of imaginary term will be different. So let's see an example to further clarify these concepts. In this example, I have given a quadratic equation which is x square plus 2x plus 2 equals to 0. I have to find roots of this equation. So let's quickly check if the roots of this equation will be complex, distinct or real. So we check the value of b square minus 4ac and my b is 2, so I will have here b square as 4 minus 4, a is 1, c is 2, so 4 times 2, and my answer will be 4 minus 8 equals to minus 4, and this means that b square minus 4ac is less than 0. Therefore, the roots of this equation will be complex and those roots will be conjugate of each other. So let's find out the roots. I am going to use my quadratic formula, which is x is equals to minus b plus minus b square minus 4ac over 2a. And my b is 2 b square will be 4, 4ac will be 8 over my 2a will be 2 because a is 1. So I simplify it further, I will get minus 2 plus minus 4 over 2. So my two solutions will be, so x will have two solutions or two roots, which will be minus 2 plus minus 2 iota over 2, which is simplifies to minus 1 plus minus iota. Let me clear the board first, and then we will talk about a polynomial of higher degrees. And we will learn that when a polynomial of degree 3 or 4 will have complex and real roots. And we will also do an example, so stay tuned. So we have learned from coordinate equation that when an equation has a complex root, then it has basically two complex roots, and those roots are conjugate of each other. We can apply the same rule for higher degree of polynomials. So let's say I have a polynomial of degree 3 that means my polynomial is ax cubed plus b x squared plus c x plus d equals to 0, where a cannot be equals to 0. For such a polynomial, I will have three roots because the degree of the polynomial is 3. And because complex roots always are in pair, therefore I can have either 3 real roots or I can have 1 real root and 2 complex roots, where these 2 complex roots will be conjugate of each other. Similarly, what about polynomial of degree 4? We can extend it on degree 5, degree 6. So what about polynomial of degree 4? Now we will have multiple cases. In this case, I could have either 4 real roots, I could have either 2 real roots and 2 complex roots, where these complex roots will be conjugate of each other. Or I could have 4 complex roots where these roots will be in pairs. Each pair will be conjugate of other complex root. So I will have in this case my root alpha and my root alpha conjugate. I will have my root beta and my root beta conjugate. So let's do another example to make those concepts crystal clear. In this example, I am given a polynomial of degree 4, which is z raised to power 4 plus 13 z raised to power 2 plus 36 equals to 0. Additionally, I am also given a root of that polynomial, that is z is equals to 2 iota, and I am asked to find remaining 3 roots because the degree of the polynomial is 4, so it has 4 roots. Now we will use our concepts about the complex roots, because complex roots are always in pair. If I have given this root, which is z is equals to 2i, then I will have another root which will be conjugate of this root. That means in that case iota sign will be different. So I will have another root which is z is equals to minus 2i. After finding these 2 complex roots, I can create a factor of this equation, and then I can divide this equation by its factor, and that will give me another factor of this equation, and I can find a root of that equation. So, make sense? After finding these two roots, I can say that this equation has a factor which is z minus 2 iota times z plus 2 iota, which will be equals to z square, because I'm using a plus b or a minus b formula. So it will be equals to z square minus 2 iota whole square, and this simplifies to z square plus 4. This is a factor of this equation. So in order to find another factor, I will divide this equation by this. So my first quotient could be z square. When I multiply z square with z square plus 4, I will get z4 raised to power 4 plus 4 z raised to power 2, and then I subtract. So these will cancel with each other. I will have here 9z square plus 36. Now I multiply this with 9. I will get 9z square plus 36. So that means this equation has two factors, which are z square plus 4 and z square plus 9. I already know the roots of z square plus 4, which are these roots. I have to find roots of z square plus 9. So I have z square plus 4 times z square plus 9 equals to 0. This equation and this equation are same. So my roots of z square plus 9 equals to 0 will be that I write z square equals to minus 9. Then I square root both sides, and my roots will be that z equals to plus minus 9, which is equals to plus minus iota 3. So these are my 4 roots. My roots of these equations are number 1, 2 iota minus 2 iota plus 3 iota minus 3 iota. So this equation has 4 different complex roots. That is it for this video. I hope to see you around for the next video. Bye.